The next lecture is about nested one-time decisions. So, in some sense, this is a case where we are not making just one decision, but this one decision results in a few other subsequent decisions. But if you think about it, this is just about one thing. So, it still is one time, but there are some nesting issues that we will talk about. Now, this is an extremely contrived example, completely made up. However, it is from DeNardo's book where he talks about a mosquito situation. We have adapted that for a different application here. And DeNardo book is one of the books that we are using in our references. So, this problem is called the Greene cat recovery. My son is the one who gave me all this context, which is pretty interesting. I'll draw a picture in the next slide to explain it one more time, but let's go over this carefully line by line. Okay? The first point is, so there is this island of Leorfin, and there is a special type of cat called Greene cat. Greene is the name of a person, and it is a subspecies of that. So, the inside of this type of Greene cat, and its population is declining. Okay? So, that's what's the situation. Now, it turns out that this Greene cat is very special because its coat is black in color, okay, much like a black panther. So, if you think about a black panther, it is basically a regular panther except that its coat is black. If you go really close, you will see all those rosettes and other things. Now, the main species, okay, which is the more popular species, it's what is called the brown coated Greene cat, and that's only available in the mainland. Okay? So, there is an island which has this Greene cat, which is a black colored one, and a brown coated Greene cat in the mainland. Okay? Now, turns out the brown coat itself is what's called the dominant gene, okay? And the black coat is a recessive gene. So, it turns out many years ago there were a bunch of these black coated Greene cats that were in the island, and if you go to the island, you will only see the black coated subspecies. Okay? And the reason the population is declining is because there is tremendous amount of inbreeding. Okay? And I will come to the populations later, but so inside this island, these cats are not breeding with other cats, and there is some genetic defect that is that spreads, and therefore it is the population is declining because there is some genetic diseases associated with that. And turns out there are two separate populations of this Greene cat. So, this is an island, and the island has two separate forest areas, and in each of these forest areas there are two separately booming black coated Greene cat population. Okay? And they are not mixing with each other either, because in this day and age there are so many things that are built that these two islands are, these two forests in the island are far away, that there is no mixing. Now, turns out that if they stop this inbreeding, it is told that we could restore the declining population within 2 years. So, that is what we need to do. Okay? So, now what are the options to stop the inbreeding? So, you have been trusted with doing or entrusted with restoring the declining population, and you are given 2 years of time. Okay? Now, here are the three options that one could consider, and I will go ahead and explain all this once again using a picture in the next slide. Okay? So, now turns out that you have three options. The first option is, remember I told you there are two populations in two different forests within the island. You could crossbreed by taking some of these black Greene cats from one and put it in the other population. So, you do a switch, it is called crossbreeding. You could do that, but because of the way these people are out of their comfort zone, there is a chance that this won't be successful. So, the probability of success is only 2/3. So, there is a 2/3 chance that we could restore the population, and in fact it would be restored well before the 2-year mark. Okay? In fact, much smaller than 1 year is what is expected, pretty much right away. Now, I am putting a dollar sign. This is frequently used to denote qualitatively how much it would cost. Okay? So, for example, you see some of these are $3 signs, some of these $1 signs. So, this is midway. Okay? It is not terribly expensive, it is not terribly cheap either. Now, the second option, so the first option is to crossbreed between the islands. The second option is to do the same thing, however, instead of physically moving the cats, okay, the black colored green cats, physically moving them, we do what is called IVF, in vitro fertilization. Okay. So, that can also be done. It is a lot more expensive because you would have to manually take a cat, put them to sleep, move genetic material and so on. So it gets a little bit more expensive. However, it is guaranteed to work. So, if we crossbreed using in vitro fertilization, now in practice is it guaranteed? Probably not, but we will, to keep this problem more tractable, we are going to assume that it is practically one. Okay? And it is also right away, it does not take much time. If we decide to go with this, it just costs a lot of money. Third option, which is the cheapest of the lot, is by breeding brown green cats. Remember that the brown coat is the dominant coat, dominant gene, and the black coat is the recessive gene. So, if you go ahead and do some type of breeding in captivity in the mainland, not in the island, but in the mainland, we could create this recessive gene by chance. However, that will take a lot of trying, okay, but it is very cheap comparatively. So, that will take 1 year. Okay, so because then the cat will have to grow and then they would introduce it to the island. There is a lot of uncertainty involved. So, therefore, we are saying okay, there is a 50% chance that this would be successful. So, there is a time aspect and there is a low probability. However, it is the lowest cost. So, you have three options. One option is extremely expensive, this is the second option. It will take a very small amount of time, but it is guaranteed. The second option, not so expensive, but also not guaranteed and will take a very small amount of time. Third option takes a large amount of time, very cheap, but has a low probability. Now, we are also allowing to do combinations or all of the above or something like that, and let us see what all we could do. Now, there is another important thing. You only have 3 decision opportunities. Okay? Now, after 1 year, and then after 2 years. So, you only have 3 times you could make this decision because the breeding season occurs only once a year. Okay? So, the breeding season happens only one time in 1 year, and so you either catch it now, which is the breeding season, or 1 year from now, or 2 years from now. Now, so that is another important aspect that we need to consider. All right, I am going to, because this is not the most straightforward commonly used example, I am going to try to recreate this example in the next slide using a picture. Okay. So, let us say we have, this is our island of Leorfin and this is the mainland. Okay. Okay. And then you have a brown coated cat here. I am assuming this is brown in color. So, this is well, this is not really brown, but let us pretend that this is cat, this is brown, okay, it is a wild cat. And then here, this is black coated wild cat, I can probably just click here. So, but they are in 2 separate populations. So, this is one forest, there is a black colored green cat and there is another black colored green cat. Okay. So, now there are, so this is an island and these are 2 forests, all right, and these 2 populations here and here are separated. So, these populations are the 2 black cat populations in the island are separated. Now, there is also a brown cat family sitting at the mainland. Okay. So, your 3 options are, okay, the first option is, I am going to use red now. The first option is to move one or few black cats from one to the other and move another one from here to here. Okay. So, this so they actually physically move the cats. Okay. The second option, this is option 1. The second option is to do the same thing except instead of physically moving the cat, you will do it in a lab. we'll do an in vitro fertilization in a lab. So this is the IVF option, okay, and this is the first one is a physical option, and the third option is to breed in captivity. In captivity, and once that happens, move them here. So those are your three options, okay? And they cost different things. Now this, the first option, for example, this one is $2 signs and has a probability of 2/3 of being successful. This has $3 signs, very expensive, the probability of success being 1. This is the cheapest and the probability of success is only half. And let me see if there's anything else that I missed out. Yeah, the time as well. So and this one takes 1 year. I do want to emphasize that quite clearly, so that when we come back, we could do the breed in captivity, and after 1 year, you bring them there so that they are mature and they can be moved. So that is what we need to do. Okay. So these are our options, and we need a timeline. We need to have a timeline. What do you do now? What do you do a year from now? And what do you do 2 years from now? We can see the results and also make a decision. Okay, so you're allowed to do that too. You're not just making a decision for everything right now. You are making what you want to make right now. You'll see what happens and then make your decision next year and the year after. So let's see what our various options are. So let's do a quick analysis. So remember, I'm going to use some alphabets here. It might look like an alphabet soup, but it's not that bad. I will try to elaborate whenever I can. So we have three options. The first option is crossbreed naturally, called XNAT. So naturally move them. So this is our red color one here in this picture. The second one is crossbreed using in vitro fertilization. So that's our blue option. Okay, crossbreed using IVF. So it's called, the X is for crossbreed. And finally, the third option is to breed in the mainland in captivity. So it's called MCAP, M for mainland, CAP for captivity. So that's your third option. All right. Now, remember that we have this dollar amount. I mean, saying dollar, but it's really not going to be a physical money amount. That just tells you one is cheap, one is not so cheap, and one is not quite expensive. Okay. So we were going to use what's called a negative of a utility function. We saw in the previous lecture what a utility function was. Utility function always was a benefit. It was it was something that was positive. So it could have a negative benefit. That's one way of thinking about it, or we'll just call it disutility, and we want to minimize the disutility function on average. Okay, it's the same idea that we saw before as instead of utility. I'm calling it disutility because it's a cost. Okay, now P is the probability that in each attempt, each action is successful. Also, we must be successful in 2 years, and until success, we must do something in each time period. We have a little table here. I want to go over this table very, very quickly. So if we do this now, if we do a natural crossbreed right now, remember it has a probability of success of 2/3, then it would cost us 50 units. Okay, again, this is a utility cost. It's not real rupees or dollar cost. It's a utility cost, and it will cost 50. Now, if you were to wait for 1 year and do what we call as natural crossbreed, this is where you move one from one forest to the other forest and crossbreed them, then that would be more expensive a year from now. Why is that the case? Well, there is an increase in 20% because what happens is, as time goes by, the population declines further, and thereby it becomes more expensive. You need to find a cat, move them, and then the population is very low. There's very less chance of breeding, and very less chance of actually crossbreeding. So therefore, the cost that way is kind of going to be higher. The probability of success still remains at 2/3. All right. Now, that's the first option. Our second option is to do IVF. In the IVF option, this is the in vitro fertilization, and that you could do now itself, costing 100 units, and with probability 1, you're all done. So that's a wonderful option. Now, if you were to wait for 1 year and do it, you would spend 120, and with probability 1 you'll be done. If you wait for 2 years, it would be more expensive, but you would be done. Now, the reason you may want to wait for longer, why don't you do it now, is because it's so much more expensive. Maybe if some of the cheaper options work out, I don't even have to go for the more expensive option. So therefore, I might be inclined towards using a disutility cost that is higher in the future as a worst case situation. As a last option, we could do we could do a mainland captivity right now, but we only get to use it 1 year from now, and there's a cost of 10 units. So remember, the only time we could do that is once right now, and if we don't do it now, there's no point in doing it any time later, because it will take a long time for you to see the effects. Okay. Now, it turns out the probability is also 0.5. So this information is stated very clearly here. So notice that all the costs, this cost as well as this disutility cost, both of them increase by 20% each year. That's mainly because the population is declining, and so it becomes more expensive to perform the same action in the future. So this is our setup. We want to come up with a strategy that minimizes the expected disutility. Once again, we're using expected disutility the same way as we used the expected utility function in the previous case. Okay, that's because we already are taking care of this business of going from being risk averse to making a common objective by using a disutility function. Okay, now here are our strategies. Okay, we have 4 strategies that are possible. Now, strategy is different from what are our options. Okay, so the first strategy, as you would have guessed, is to do IVF now and be done with it. Remember, there is a do this option. There is a 100% chance of it being successful. You spend 100 units and you're done. So it will cost you 100 units and you'll be done. So we'll also do the calculation as we go. So if you look at the first strategy 1, the expected disutility cost is 100 because you spend that 100. There is no uncertainty there. You're going to get the 100 back, and that's all it's going to cost you. Now let's see what happens in the second strategy. The second strategy, we crossbreed naturally. Okay, so this is the one where this is the red option that we have here, option 1. We crossbreed naturally. And then if it is successful, we're done. If we fail, then year 1. Okay, so remember, we have year 0, year 1, and year 2. 0 is now. So right here, if we try to crossbreed, and if you're successful, we're done. If you're not successful in year 1, we will do an IVF, and then we'll be done. Okay, so we want to be done, by the way, at the end of year 2. Okay, so let's see what's that one's cost. So if you look at the cost, the expected disutility cost. So you'll spend 50 units just for the initial crossbreeding. That's the number here, the very first number here. So that you will always spend. Then after that, there is a 1/3 chance. Remember, there is a 2/3 chance that it will be successful. There's a 1/3 chance it would fail. So there's a 1/3 chance that you'll have to now spend $120 or 120 disutility costs to take care of the problem. So that's why you have 1/3 times 120. So the expected disutility is now 90. So the expected disutility has become better. So this strategy is better than the first strategy. Like we guessed earlier, that we are okay giving this a shot because there's a 2/3 chance that I'll be successful, and I could do that with a lot less money. Okay. Now let's look at the third option. The third option is a little bit tricky because we do all of them. The third option, we do the following. We do the natural crossbreeding right now. Okay, so this is the red option we had in this picture. We do the natural right now, and we also at the same time breed in captivity in the mainland. So at time 0, we start the first one, which is to crossbreed naturally as well as breed in captivity. Do both in year 1. Year 0. So this is right here, do both. Okay. Then what happens is, now if the natural crossbreed is successful, we are done. Okay. Yes, we did spend some money doing the captivity stuff, but that's okay. Now, if it failed, then what we do is we introduce these cats in the island after 1 year. So, at year 1, if it fails, we introduce those cats, and if that is successful, we are done. Otherwise, we do IVF in year 2. Now, there is a reason we don't do IVF also in year 1, because you've after all gone ahead and done this captivity breeding. So, it doesn't make any sense. You can actually do the analysis and see that those strategies need not even be considered. But if you think about it, yes, in theory you can write down all the various strategies, but those are not going to be there for us. The last strategy, before I do the last strategy, sorry, we have to also evaluate the cost. The cost of the strategy is the $50 that you have to pay to do the crossbreed naturally in year 0, that's the time right now. Then there is a 10 charge to also do the captivity in mainland. Okay, so that's the $10. So you also pay that. So initially you do both. So 50 plus 10. Then there's a 1/3 chance that you would fail. Okay, and there's a 50% chance that the breeding in captivity will fail, and you must then do the IVF in year 2. So therefore, that would cost 144. So if you think about it, we are looking at this probability multiplied by this. So you need both to happen. It failed both in the right. That's the only time you're going to incur this cost, is if both fail, both the 0th year XNAT and the first year's the first year's MCAP. If both fail, then you'll have to incur this cost, and if you did the calculation, it's 84. So by far it's the cheapest. In fact, you'll see that that is the optimal thing to do. But let's look at the last strategy. So last strategy says we will do a natural crossbreeding right now, but we will not do the mainland captivity. So the natural one is successful, then we're done. If the natural one fails, you try natural again in 1 year. Okay? If it is successful, then we are done. If not, we'll just do IVF at the last year. Remember that you have to be successful at the end of the at the end of 2 years. Okay, so at the end, if nothing works, you will do IVF here. So we try once using the natural crossbreeding. If it doesn't work, try that again after 1 year. If it doesn't work, then go ahead and do IVF in year 3. Let's compute the cost. $50 first time anyway. If it is unsuccessful the first time with probability 1/3, you multiply that by 60, which is the cost to doing it the second year. Okay. Now, if that is successful, you're done. If it is unsuccessful again, so both years unsuccessful, then you will spend 144 units and do an IVF. The resulting cost is 86, slightly more than strategy 3. So the optimal strategy is strategy 3, which is to do the natural crossbreed right now, and at the same time start planning the in the mainland to do the breeding to see if we can get a recessive gene, and then introduce them a year from now, and then if that also fails, finally do the IVF. So that's the optimal strategy. So we'll stop here and move on to decision trees next. Thank you.